projects. In this video, we are going to explain about a project titled Missing Data Imputation using Machine Learning Algorithm for Supervised Learning. Our project addresses the pressing issue of the missing the data in the today's data-driven world. The absence of data can significantly impact the reliability of supervised learning model, leading to biased outcome and reduced accuracy. To overcome this challenge, we are utilizing the state-of-art machine learning algorithm to create a robust solution for predicting and replacing the missing value. The result will be complete and dependable dataset, enhancing the effectiveness of data-driven approaches. Our primary goal is to develop a powerful toolkit that empowers the data scientists, researchers, and professionals in various industries by rigorously evaluating the different algorithms based on imputation accuracy, computational efficiency, and adaptability. To diverse the missing data pattern, we aim to provide a comprehensive and versatile solution. Ultimately, this project seeks to foster more informed decision making and encourage the innovative data-driven solution in a wide range of fields. The main goal of our project is thoroughly assessing the various missing data imputation methods, including KNN impute, mean, forward fill, and the backward fill techniques, and the conjunction with decision tree algorithm for supervised learning. Our approach involves conducting the extensive experimentation and analysis to identify the most effective imputation technique that achieves the highest accuracy in the decision tree based model. Furthermore, we aim to investigate how each imputation method impacts the computational efficiency of the decision tree algorithm. Through this comprehensive evaluation, we seek to provide the valuable insight to the data scientists and researchers, enabling them to make the informed decisions when selecting the optimal missing data of the imputation techniques. By enhancing the predictive capabilities and overall performance of the decision tree model, our project aims to contribute to more accurate and reliable data-driven decision-making process benefiting a wide range of applications and the industries. Ultimately, the project aims to enhance the field of supervised learning and foster the use of robust data imputation method for improved data analysis and the decision making. These are the basic requirements that are needed to build this project. The software requirement: Python IDEL with version of 3.7 or Anaconda with version of 3.7 or Jupyter. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. To know about the flow of the project, these are the modules we need to discuss. The first one is importing the libraries. In this step, essential Python libraries and modules are brought into the environment. These libraries play a crucial role in the data processing, analyzing, visualization, and machine learning tasks. For this, Pandas is employed for the data manipulation and the handling. Matplotlib and Seaborn are used for data visualization. sklearn offers the machine learning algorithm, and many more. The second one is importing the Cleveland dataset. The Cleveland dataset is one of the heart disease related dataset being utilized in this project. It contains the medical data pertaining to the patients, including the features such as age, sex, blood pressure, cholesterol level, and other relevant medical measurements. And the third step is of importing the Hungarian dataset. Another heart disease related dataset called Hungarian dataset is imported. While it is also related to the heart disease, it might have distinct features and the data characteristics compared to the Cleveland dataset. And then the next step is importing the Switzerland dataset. The Switzerland dataset, which is at another heart disease related dataset, is imported. And the next step is importing the Long Beach dataset. The dataset is potentially related to that heart disease and it contains a unique set of features and the target variables within it. And the next step is combining all these datasets. In this step, the dataset imported from the previous steps are merged into a single set. This combination can be achieved by stacking the dataset vertically or horizontally, allowing the creation of a larger dataset that incorporate the information from all the individual datasets. And the next step is checking for the null values. The combined dataset is now checked for any missing value or the null value in its column. Identifying and handling the missing data is crucial as it can significantly affect the accuracy and reliability of the subsequent analysis and the machine learning model. And the next step is applying the KNN impute with decision tree. The KNN impute method is employed to fill in the missing value within the dataset using the k-nearest neighbor approach. Once the missing data is imputed, a decision tree model is trained on the complete dataset. The decision tree algorithm is of machine learning technique used for the classification and the regression task. And the next step is applying the mean on the decision tree. In this step, the mean method is used to impute the missing value by replacing them with the mean value of the respective feature. The imputed dataset is then utilized to train another decision tree model, enabling the model to make the predictions based on the complete data. And the next step is FL method on the decision tree. The forward fill method is applied to impute the missing value by copying the previous non-null value in the same column. The dataset with filled values is then used to train a decision tree model for the prediction purpose. And the next step is bfill method on the decision tree. The backward fill method is employed to impute the missing value by copying the next non-null value into the same column. A decision tree model is then trained on this imputed dataset. And the next step is training the model. After applying the various imputation techniques, the final data set is splitted into the training and the testing. The training set is utilized to train the decision tree model, enabling it to learn the pattern and the relationship in the data and then make the accurate prediction. And the next step is user gives the input. A flash web interface is set to interact with the users, providing them with the ability to input their data or queries that are related to the heart disease. And the next step is the given input is pre-processed for prediction. The user input provided through the flash interface is pre-processed to ensure that it conforms to the required format and is suitable for making the prediction using the trained decision tree model. And the next step is trained model is used for prediction. The pre-processed user input is fed into the trained decision tree model. The model processes the input data and make the prediction based on the learned pattern from the training data. And the last one is final outcome is displayed. The prediction result from the decision tree model are displayed to the user through the flash interface. The outcome include information on the likelihood of the heart disease presence or absence based on the user input. The displayed information aims to provide the valuable insight for the user reference, facilitating informed decision making. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder containing of the different files within it. The first one is dataset folder containing of the various types of datasets within it of heart disease, and the static folder containing of the image within it, and the template folder containing of the HTML files within it, and the app is an py file which contains the information related to the front-end logic. It includes the code written in Python that handles the server-side operations such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And this is an IPYNB file which contains a combination of the code, graph, output all in one place. It allows the user to write and execute the code in individual cell, making it a popular choice for the data science. And it is an model.pickle file which contains the algorithm information within it. It loaded into the project code during the runtime to utilize the trained model for the various tasks, such as making the prediction on the new data or performing the specific operation. First, to execute the project, we build and Flask framework, and the overall project code is present in the IPYNB file in the form of code, graph, and output all in one place. For the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here first we need to change the location of the disk as of F because our code folder is present in F disk. Then write a command cd space and paste this code folder address. By this it will redirect to the code folder's path and then click on enter button. Here we need to write a command this python space app.py. By using this command, it will execute the Python script and perform a runtime check for any syntax errors or the logical issues. And then click on enter button. By this, it will view an default address like this. We need to copy this local link and paste it on any of web browser. I prefer to use the web Chrome. And copy this local link and then click on enter button. By this we redirected to the page like this. Here we need to enter the details, the age of the person as of 63 and the sex as of 1 and the CP as of 4 and trust BPS is of 140 and the cholesterol is of 260 and the FPS of 0 and rest ECG of 1 and tal of 112 and xang of 1 and old peak of 3 and the slope of 2 and the CA of 2 and the tal of 3 and then click on predict button. Here it's predicted as oops you have heart disease. For another prediction we need to click on back button and refresh button. It will read back to as of like this. Re-enter the details as age of 44 and sex as 1 and CP as 4 and trust BPS as 130 and cholesterol as of 200, 209 and FPS of 0 and rest ECG of 1 and the tal AC of 127 and xang of 0 and old peak of 0 and slope of 1 and CA of 1 and tal of 1 and then click on predict button. Here it predicted as you don't have heart disease, and this way we can predict the heart disease by taking off missing values within it. And here in conclusion, our project explored and compared the various imputation methods including the KNN impute, mean, F-fill and B-fill and the conjunction with the decision tree algorithm. Rigorous evaluation revealed insightful findings that can significantly impact the data-driven decision-making process. The F-fill method demonstrated with the highest accuracy among the imputation technique, which indicating its effectiveness in enhancing the predictive capability of the decision tree model. While KNN impute and the mean methods also showed the competitive results, the computation complexity was notable. Overall, the findings underline the critical importance of addressing the missing data in the supervised learning scenario and the potential of the trial imputation methods to boost the model performance. Armed with this knowledge, data scientists and researchers can make the informed choice to ensure the integrity and the accuracy of the analysis, advancing the realm of the machine learning applications in the diverse industry.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe. Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.